Kai and Anne carry out a survey on the distance traveled in kilometers by 200 cars. Kai complete this frequency table for the data collected. So the distance and frequency is given there. Calculate an estimate of the mean. So to find out the mean, x bar, we know the formula is summation of fx divided by summation of f. Summation, or it's also called sigma here, sigma fx by sigma f. Now, f is the frequency, x is the midpoint of the class intervals. So we already have the frequencies and we need to find out the midpoint. Sigma fx means adding up all the fx values. Sigma f means adding up all the frequencies. So I prefer always a vertical column instead of a horizontal one. So I'm just going to draw a vertical table here. So class intervals are given here. Class interval is 80 to 100, 100 to 150, 150 to 200, 200 to 300, and 300 to 400. The frequency is also mentioned, so let's just write down the frequencies: 7, 33, 76, 52, and 32. We need to find out the midpoint first, midpoint of the class intervals. 80 and 100, the midpoint will be 90. We know the formula for the midpoint is upper limit plus lower limit divided by 2. Upper limit plus lower limit divided by 2. So in this case, 80 plus 100 divided by 2, 90. But in all these class intervals, it's easy to find out the um, midpoint by just looking at the intervals. 100 to 150, I know it is 125. 150 to 200, it is 175. 200 to 300, it is 250. And 300 to 400, it is 350. Now, fx, we need numerator summation of fx or sigma fx. So we need to multiply f with x. So fx values. 7 into 90. For that, we can use calculator here. 7 into 90 is 630. 33 into 125 is 4125. 76 into 175 is 13,300. 52 into 250 is 13,000. And 350 into 32. 350 into 32 will give us 11,200. Sigma fx means adding up all of these f of x values, we will get sigma fx. So that is 630 plus 4,125 plus 13,300 plus 13,000 plus 11,200 will give us 42,255. Sigma f means adding up all the frequencies. It's also given here that there are 200 cars. So sigma f will be 200, but if you add them up, still you will get sigma f as 200. So now we can find out the mean here. Estimate of the mean is sigma fx, that is 42,255 divided by 200. So that will give us 211.275. So the first part is done. It was a 4-mark question. Now, and uses this frequency table for the same data. There is a different interval for the final group. So all the other intervals were just the same. The only difference is in the final interval. For Chi, the final interval was 300 to 400, whereas for Anne it was 300 to 360. Without calculating an estimate of the mean for this data, find the difference between Anne's and Chi's estimate of the mean. You must show all your working. So we know that for Chi, the class interval was 300 to 400 and the frequency was 32. Whereas for Anne, The class interval is only 300 to 360 and the frequency is 32. Without using estimate of the mean, how we can find out is find fx of both of them. Fx means frequency multiplied by the midpoint. Here the midpoint is between 300 and 400. We know the midpoint is 350. Here the midpoint between 300 and 360, that is 330. So Fx will be frequency is 32 into midpoint is 350. 32 into 350 will be 11,200. Now again find out Fx here. F is 32 and midpoint is 330. So 32 into 330 will give us 10,500 and 10,560. We need to find out the difference between their estimate of the mean. So subtract them both. 11,200 minus 10,560. So 11,200 minus, you'll get 640. 640. And we know mean, estimate of the mean formula, sigma is, x bar is equal to sigma fx by sigma f. So here we found out fx, both the fx values, only the change was with the last interval instead of 300 to 400 for chi, and is having 300 to 360. After finding out both the fx value, you subtract them. So that is 640 divided by sigma f is 200. Sigma f was 200, isn't it? Because frequency, when we add them up, we'll get 200. 640 divided by 200 will give us 3.2. This will be the difference in their estimate of the mean. 3.2 will be the final answer. Let's move on to the next one here. A histogram is shown drawing the information in Chi's frequency table. A height of the block for the interval 200 to 300 is 2.6 centimeter. So histogram, if we go back to what we studied about histogram, the y-axis is always frequency density, and we know the formula, frequency density is equals to frequency divided by class width. In this case, from Chi's frequency table, the frequency density here is mentioned as 2.6. The height of the block means it is the frequency density. Frequency density is mentioned as 2.6. So let's find out original frequency density according to Chi's frequency table. Let's take a look at the Chi's frequency table. Between 200 to 300, between 200 to 300, if you're finding out frequency density, frequency is 52 and class width is between 200 to 300, it is 100, that is 0.52. 0.52 is the actual frequency density from the Chi's frequency table, but this 0.52 is represented in the histogram as 2.6 centimeter. Now, we need to find out the height of the block for each of the following intervals between 80 to 100. So let's check 80 to 100. 80 to 100, there were, if we find out frequency density between 80 to 100, frequency is 7, class width is 20. So let's find the decimal. 7 over 20 will be 0.35. 0.35. So now we know that 0.52 is represented as 2.6 centimeter in the histogram. So 0.35 will represent how much centimeter in histogram? Cross multiplication. So 0x into 0.35 into 2.6 is equal to 0.52x. X will be 0.35 into 2.6 divided by 0.52. So 0.35 into 2.6 divided by 0.52 will give us 1.75. This will be 1.75 centimeter. Now, the next part here, between 150 to 200. Between 150 to 200, between 150 to 200, the frequency density is frequency is 76 and class width is 50. So let's find out the decimal conversion. 76 divided by 50 is 1.52. We know that 0.52 frequency density is represented in the histogram as 2.6 centimeter. So 1.52 frequency density, what will be its centimeter in histogram? Cross multiplication. This is basically 1.52. You multiply with 2.6 divided by 0.52. You'll get it as 7.6. Get it as 7.6. And finally, the last one, the interval which they are asking is 300 to 400. So between 300 to 400, let's first find out what the frequency density is. So I'll just use this space here. Frequency density is frequency is 32, 300 to 400. It's not this one, but here 300 to 400, it is 32. So frequency density is 32 divided by 100, which is 0.32. Now, we know that 0.52 represents 2.6 centimeter in histogram. So 0.32 will represent how much? Again, you cross multiply. 0.32 multiplied by 2.6 divided by 0.52. You'll get it as 1.6. So this will be 1.6 centimeter. So we got the corresponding heights of the class interval in histogram. So now moving on to the next one. One car is picked at random. Find the probability that the car has traveled more than 300 kilometer. So probability, we know the formula. Probability of an event is number of favorable outcomes divided by total number of outcomes. So here we need to find out how many cars is traveling more than 300 kilometer. So let's check the table here. For Kai, we have more than 300, it is 32. 32 out of 200. Out of 200 cars, there are 32 of them is traveling more than 300. So we can further simplify this. 32 divided by 200 will give us 4.25. 4.4 over 2, 25 or 0.16. Now, the last one here, two of the 200 cars are picked at random and find the probability that both the cars have traveled 150 kilometer or less. So again, going back to the frequency table, 150, both the cars are 150 kilometer or less. So 150 kilometer or less means 33 plus 7 less than 150 means it should we can consider only these two. So 33 plus 7 is 40. There are 40 cars out of 200, and that is for the first attempt. If we are selecting a car which is traveling bit less than 150 kilometer, probability is 40 out of 200. Now that is being separated. Now we have one car less from 200 for the second attempt. That is 199. And then we don't have 40 cars now, which we have only 39 remaining. 39 remaining because one we have already separated. So 40 into 39 divided by 200 into 199 will give us 39 over 995. This will be a final answer for the first subdivision. And the last one, One car has traveled more than 200 kilometer and the other car has traveled 100 kilometer or less. So one of them is more than 200 and the other one is 100 or less. So here, more than 200 means 52 plus 32, that is 84. 84 out of 200 will be the probability of getting a car which has traveled more than 200 kilometer, and then the next car should travel below 100 kilometer. Below 100 kilometer means it is 7 over. Now we have only 199 cars. So 84 into 84 into 7 divided by 200 into 199, which will give us 147 over 9,950. But in this case, we have one more step, because here first attempt I'm getting a car which is traveling more than 200 kilometer, and in the second attempt I'm getting a car which is less than 100. It can be the other way around also. That means in the first attempt I'll be getting a car less than 100, and in the second attempt I'll be getting a car more than 200 kilometer. So basically there are two combinations. If we have two combinations, you have to multiply this with 2. So when you multiply the answer by 2, you will get it as 147 over 4,975. This will be the final answer. So we are done with all the subdivisions for this. It was a bit lengthy question, but initially to find the estimate of mean, we used sigma fx by sigma f formula. Then we just have to find out the difference in the fx values of the last interval and divide it with sigma f to get the second one. Third one, we used the frequency density formula, that is frequency over class width. And finally, the probability formulas. Probability of an event is number of favorable outcomes divided by total number of outcomes. So I hope you have understood this. If you have any doubt, feel free to write it in the comment box. Thank you for watching.